Okay, this is Andrew. This is CS332 Project number 1 and 2, the IP addressing plan and the routing table. Okay, so this is the rubrics. If you go ahead and look under tests and assignments, you'll see this positioned under there. Given a network diagram for a company with 2 campuses, 3 locations, and at least 2 countries, the students will develop IPv4 and IPv6 numbering plans. It'll include a DMZ with several servers. The numbering plan will include the numbers assigned to the servers, the routers, interfaces, and segments, including appropriate masks and CIDR designations. Okay. Also included will be explanations of why particular numbers or sets of numbers were chosen. The student will detail the number of public IP addresses needed and explain how that number has been kept to the minimum necessary. The student will include an example of implementing IP addresses on a Linux workstation, a dual-ported Linux server, and a Windows-based computer, and also for router interfaces. Okay, so you can read here the exceed standards. The student can create an optimal and effective addressing plan, including considerations for future expansion and changes to the systems for IPv4 and 6. The student uses NAT effectively in the addressing plan. Okay, so here's the outline of the project. Basically, we're going to design the network to provide for 20% growth to conserve network IPv4 network address space. So this means you must use variable length subnet masking. Okay, so for example, if you have 100 computers, you're going to need 120 IP addresses because that's the 20% growth. And then you're going to choose the subnet block, the minimum subnet block that is required to meet that requirement. So that would be the 128 subnet block. Okay, so you get that. All right. Network topology and addressing. So design the IP addressing for your network, and then you want to use public IP addresses and private IP addresses where appropriate. Then you want to label which routers will need to perform NAT and PAT or PAT. Okay, and then you're going to include step-by-step instructions to assign an IP address to a Linux workstation, a dual-ported Linux server, a Windows-based computer, and an interface to a router. And then you're going to repeat all steps 1, 2, and 3 for an IPv6, and then produce a PowerPoint presentation for the network and tables clearly describing all the IP address ranges, including CIDR notation and subnet masks. Okay, so for those of you that have had CS308, this is basically the same thing as Project 4 in that course. So I know some of you are, at this point, IP addressing gurus, so you can pull up your Project 4 and modify it to meet this. Okay. So this was basically Project 4 in IS308. So we're going to simplify this a little or change it. We got rid of the firewalls. Now this is the WAN. So what you need to do is determine your IP addresses. Now you need public IP addresses and you need private IP addresses. Okay, so inside this network here, so you need your private IP addresses. And you need a different network or subnet for each branch of the router, right? And then this right here is going to be its own network. I hope you see that. And the interface, don't forget to put the IP addresses on the router or the interfaces. You don't have to obviously assign each one of these computers. Just assign a range. So it's 120. So you would do from 1 to 121. So 192.168.1.1 to 192.68.1.121. You get the idea. You don't have to write 120 IP addresses here. Just do the range, like that's all. So you want to do the range of IP addresses for each branch of these routers, right? Each branch of the routers. And then you want to label which routers you need to do NAT or PAT on, okay? Okay, so let's take another look at that. After that, you're basically done with the IP addressing plan. Once you do all that, you want to write all that up, obviously. Include tables of all your IP addressings. You might want to use the IP addressing subnet calculator that I showed you. Go ahead and use one of those. Check that everything you did is correct. Include screenshots of all of that, and that will meet your project 1 requirements. Okay, so project 2 is a routing table. So the student will create and enter static routes for the designated computers and routers in the network which they devised an IP addressing plan for in the previous exercise. And you will demonstrate end-to-end connectivity for the systems through the use of ping and trace routes. Actually, you're going to use extended ping, okay? I'll explain that to you in a minute. So here's the rubrics. This is where your grade's coming from. The student demonstrates a clear understanding of the route through the network. Now I have to grade by these rubrics. Understand that. The student demonstrates a clear understanding of a route through a network. So if you work on these routes in GNS3 and you work as hard as you can and you just can't get stuff working right and you know it's not working right, but you explain what it should be doing, then you've demonstrated to me that you understand what the route is supposed to be doing. If the worst case scenario is if you do something and it's wrong and it's not working right and you don't even know it and you think that you're like, hey, I completed this project, I should be getting 100. Well, that's not a good sign, okay? So I understand we all have problems on every, sometimes projects go perfect, you get it all done. Other times you have problems, you work through them, and then other times, sometimes you just never get the problems done. That happens. But as long as you explain what it should have been doing, how you could have improved it if you did it over, things of that nature, then you're not necessarily going to get a bad grade, okay? You're not going to get 100, but you're not going to get a bad grade. All right, so, well, it depends on your definition of a bad grade. But anyway, so tool use. The student is able to use traceroute, ping, and other tools. What are some of the other tools? Of course, GNS3, Wireshark. I think that's all we'll be using for here. All right, so let's go in and take a little more in-depth look. So this is the steps or the outline. You want to assign yourself public IP addresses from the service provider as needed. Perform NAT and PAT on the appropriate routers. Complete all required static routes on all routers and test for full connectivity using both extended ping and extended trace routes. So here's the network. And you're not going to do all these computers, right? All these PCs, that would be nonsense. But what we need to do is model this in GNS3. So the way we're going to do that is simplify this down to 1, 2, 3, 4, 5 routers, right? And 1 switch. And then also you have these servers here as well. So what you're going to do is use, well, let's follow these steps right here. Assign public IP addresses. Use your addresses from project 1. So what you're going to do is assign the network. So whatever your network or subnetwork was for these computers, these PCs, you're going to assign that to this loopback address. Now, this is kind of misleading because the loopback address is the loopback interface is logical and it's internal to the router. So there's not really something hanging out here, but I have to draw it. So what you want to do is assign your network to this loopback interface. And then this subnet or network to this loopback interface. And the same with all of these. So you'll have loopback interface, loopback, 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 loopback. And then this will be a loopback and this will be a loopback. Now what about handling this network? Okay, you want to use your switch right here that you created by inserting the switch module into a router. Now be sure to only use the switch interfaces, not the router interfaces when you plug. Down here, what you probably want to do is, like you did in CS330, is just use a router, change the picture to a server, and assign an IP address to the interface of the router, and put it on the same network as you put the interface of this router on and the interface of this router on. So you see this is a network. You're going to need 3 IP addresses, 1, 2, 3. Okay, now after you've done all that, you've got to do pat. We're going to do pat at the hub. So you're going to do pat here somewhere. Which router are you going to do pat on? Well, that's for you to determine. And then you're going to do NAT at the remote site. So how are you going to do that? Again, that's for you to determine how you're going to do NAT at the remote sites. Okay, and then you gotta make sure you have your public IP addresses. So you gotta have a public IP address from the internet service provider. You gotta do your translation to your internal private network. So I think that should be pretty straightforward. You should be able to do that by now. And then what you want to do is use Wireshark. Okay, you're going to use, like, say for example, if you have NAT on this router, you want to look at when you ping from this interface over here to this interface over here. What you want to do is look right here with Wireshark and look right here with Wireshark and see that the translation occurred from the public IP address to the private IP address. Hope that makes sense. And then that's another point from extended ping. You can Google extended ping. So on this router, if I were to ping this interface over here by pinging one of the IP addresses on this network, then it would go from this router over here. Okay. Well, if I do extended ping, I can extend back into this loopback interface and extend and ping from the loopback interface over to here. And that's what I want you to do. I want you to ping from the loopback interface. So that means you got to do NAT and PAT translations, and you've got to. So let's recap here. So you've got to assign your network IP address ranges to each one of these loopback interfaces. You've got to do the NAT and PAT translation, and then you've got to put the static routes required on each router to give you full connectivity. Okay, so just do one server here and just do one server here. That's it. That's all. Okay. So summary. Do a show IP route and a show IP interface brief on each router. Take a screenshot and attach it to your write-up. Okay. So I want to see the IP addresses you have assigned to each interface, including your loopback interfaces, and I want to see your routing tables on each router. Okay. On each router. Okay, use extended ping. We already discussed that. Use extended ping to ping each loopback interface from each other loopback interface. Take a screenshot and attach it to your write-up. Use Wireshark to verify NAT and PAT translations. That's pretty straightforward. It's already included in GNS3. You just open it up on the interface. We use that plenty in CS332. If you're not familiar with it, I'll pull up one of the videos from 230 and put that up to show you how to use Wireshark. And again, take a screenshot before and after the translation, show the IP address translation, and then do your conclusion. Describe the problems, what you learned in these two projects, and how you would improve it. Sorry, I'm not doing the whole video over for an eye. How you would improve it if you were to do it over. So basically, again, like I said, if you work on the project hard and you know that it's not working correctly, and you explain how it should be working, what it should do, that goes a long way, because not me, right? I'm grading by the rubrics, and that's because that's what the rubrics say. The rubrics say I have to grade by the rubrics. That's my job. The rubrics say the student demonstrates a clear understanding of a route through a network. Okay, so try to demonstrate that. Even if you fail to get it working, try to demonstrate it. All right. All right, well, I hope that this should be a fun project. I think if you've had CS230 and IS308, it should be pretty straightforward. You'll learn some and have some fun. If you're missing one or two of those classes, you're going to have to dig a little deeper, but it's still just straightforward stuff. Basically, all you're doing is assigning IP addresses, static routes, and NAT and PAT, and then you're using extended ping to ping it out. So It's pretty straightforward, and I hope you have a lot of fun, and good luck.